Welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful that you pass as you reach.
Hello and welcome to another edition of MetalForming Live, our final program for 2024. Thank you all very much for signing on today, and thank you for your patience for the last 5 minutes or so. I'm Brad Coogan, I'm Editorial Director of MetalForming, and I'm joined today by Senior Editor Luke Kren here at PMA headquarters, as well as our Senior Editor Kate Bachman, who's joining us online. This edition of MetalForming Live on the shop floor details recent additions of servo mechanical presses at Concord Tool and Manufacturing in Michigan and TNC Stamping in Alabama. Both of these manufacturers have benefited from increased capacity and productivity through their new servo press additions, helping them to better achieve their to serve their automotive customers. We've got 5 panelists joining us today and nearly 100 viewers joining us online. So as always, we welcome your feedback and input. So those of you online, please ask questions of our panelists throughout today's program. So we'll get started first by introducing our panelists. Kurt, you want to go first? Kurt, I think you're muted still. Yep. Kurt.
There we go. Good afternoon. My name's Kurt Jensen. I am the president of Concord Tool and Manufacturing. Have been in automotive industry for the past 30 years and looking forward to the event this afternoon.
Thanks. And how about David? You can go next.
Yes, thank you. Thanks for inviting me. My name is David Diaz. I'm with Nidec Press and Automation. What I do is I travel the world optimizing production rates with servo presses.
Okay, thank you, David. Scott, how about you?
Hello, this is Scott Brado from Shea America, Director of Sales. Been with the company for about 25 years now. Looking forward to the event and good feedback from everybody.
Thanks, Scott. And then how about Mark over at TNC?
Hi, I'm Mark Coleman. I'm currently president of TNC Stamping. I've been here for about 34 years. Prior to that, I spent about 10 years in the engineering area for an automotive supplier. And so machining and automotive was my background before I came here. And I'm over an owner also of TNC Stamping.
Thank you, Mark. And then last but not least, Troy over at TNC.
Good evening, Troy Hardaway, production manager at TNC Stamping.
Thanks, Troy. All right, so we'll go ahead and get the show started. Concord Tool and Manufacturing, as you learned just a second ago, installed a new Nyquist servo press in May of this year. The 440-ton press has improved throughput on some tools by 2 to 3 times compared to running the tools on conventional presses. Its new line includes a Nidec CHS, fully automatic and integrated feed line. Concord ships some 1.5 million parts per week to automotive OEMs, primarily Toyota and GM, consuming 1.5 to 1.7 million pounds of steel weekly. So President Kurt Jensen, he's here to discuss the firm's experience with its servo press and its plans to add a second servo press, an 810 model, early in 2025. Kurt, go ahead and give us an overview of Concord and how you're using that servo press.
Yeah, absolutely. So yeah, Concord, we're about a $75 million a year company. We have been in business for about 60 years. In 26, it'll be 60 years. Have 11 stamping presses. All of them have been your typical mechanical type presses. So this is our first dabble in going to a servo press, and we've had some very good success with it. When we were looking at presses and shopping around a little bit, really our key reason for going with a servo was really tied to electrification of vehicles and going to some higher tensile strength, potentially some more elongation requirements, and really the control that you can get through a servo is much greater than you could pull with a conventional press. For us, as far as results, been really phenomenal. We've had some great success. Most cases, at least doubling our strokes per minute, which is a big deal when you start doing the math and adding up what a 25 stroke improvement across 3 shifts. You pretty much pick up about 9 million parts a year compared to a conventional press. So it's been a big deal for us. Some of the other things that we found with our servo press is just with the amount of control that we have as we're coming through our stroke. It's really impressive. We've been able to see gains in our tooling area. Really, it's cut our tooling PM and sharpening down by about 50%, because as you can lower it down, and most of our profiles we're able to run with in tandem mode. And so the press is not using the full stroke as a historical press would do, where you're having to go through the whole process wheel in the full up and down stroke. We're able to narrow right down onto our tool and onto the steel and really cut our strokes down. And then as we come into the part, we will back down and kind of soften the impact and then pull back away quickly. So you're really not moving parts any more quickly. You're just taking less out of the stroke, and it has been a real benefit to us. As was mentioned, we are putting in a 800 ton, and that will go in March of this year. So we're excited about that. We did get the benefit of having David Diaz, who is also on this in this meeting, come out and train our operators and get them dialed into some of the optimization techniques that he uses. And with that, our dice setters have really been able to run away with it and create profiles that have been beneficial to us. So we've been very happy with it and excited to get the next one in.
Kurt, thank you very much for that overview, and we're going to go into a little bit more detail about the press line and some of its features and benefits in a little bit. But before we do that, we do have a video shot on the shop floor over at Concord. So we're going to show that video. You'll get to see the press and the feed line running, and David Diaz from Nidec Minster is going to kind of narrate over that video and tell you what we're looking at. So let's roll that video.
Yeah. Thanks, Brad. Yeah, here, well, in this video, we have a GS2 400 Minster servo press. Here it's attached to an HDX feed line, and it's running at about 50 strokes per minute, which is almost 70% increase compared to how it was running before in a mechanical press. Well, to describe this line a little bit more, we start, the decoiler can handle up to 30,000 pounds coil, 60-inch wide. And really, this line is meant for advanced high-strength steels, ultra high-strength steels with yield strengths in this market up to 200,000 psi, which is about 1,400 megapascals. The thickness range that the line can handle is also very wide. We can have from as thin as 18 thousandths all the way up to half an inch. So this is a great benefit that you can use all this range of material thicknesses. We have one control. The feed is integrated with the press control, which is also very beneficial. And for example, when you load the tool in the press, automatically it's going to be loading it in the feed line. So this saves time for the operators and also prevents from errors, right? We have other features in the line that also help to speed up coil change and setup. For example, we have a brake roll advisor. The operator enters some of the material properties such as thickness, yield strength, etc., and we give you some of the setups to keep your material as flat as possible. Also, for example, drag brake pressure. We know as the coil is consumed, the weight is going to change, but almost never the operators actually take the time to go and change it. We can do it for you automatically. We have that feature as well in this line. So a few more things that ease the job. For example, now let's talk about the feed. The feed is an MX600 SP, and the name comes from servo piloting, which is super, super important when you are working with servo presses. Why? Because really servo presses take a lot of the time for feeding, make it a very small, and you need to feed very fast. So servo piloting helps you to do that. You can control it with a servo motor instead of mechanical stops, which make it most faster instead of air. And yeah, we can do feeds, for example, in this job that you are seeing in the video. It takes about 300 milliseconds to feed a bit more than 3 inches. So very, very fast. If you have a servo press and you don't have a servo pilot, really you are missing out a lot of the benefits. We have one control, one screen where we can program the press, we can program the feed, so eliminates that walking from one place to the other. And we have the kinematics of the feed embedded in the same control, so they talk to each other, and we know if really we are overworking the feed or if we are balancing pretty much the feed performance with the press performance. As well, now let's talk about a bit about the servo press itself. It's a 400 metric tons, 440 US tons. It's about 14-inch stroke, and in pendulum, it can go all the way to 105 strokes per minute. This press comes with a global production control, which is very user-friendly, friendly control. So what we are seeing now, it's one of the jobs that Concord has. And it was very interesting because this job was running previously at 30 strokes per minute. And when we find out what's the bottleneck for this job, it was the upstroke, not so much the downstroke, but the upstroke, because the press, when you increase the speed so much, the part started to bounce and to jump over the sensors, the part out sensor. So we were getting a lot of faults with the part out sensor. So we focused on controlling the upstroke speed, and we found that sweet spot, right, when everything was working. We had two choices. We could go like 60 strokes per minute and double production, or we can stay at 50 and go through the bottom dead center slower. So we get higher production, but also we take care of the tool life. What I recommend is we stay like this. I recommend to Concord, we stay like this until we see if we get benefits in tool maintenance. And after that, we can decide whether to go faster or not. And I'm sure we will talk more about this very soon. So that's it. Thank you.
Thank you, David. Yeah, really nice explanation of what's a fairly complex production line. So some follow-up questions, and if questions from the audience, go ahead and use that Q&A panel if you want to ask Kurt or David a little bit more about this operation. Kurt, I know when I visited you all a couple months ago, one of the things you guys really stressed was the integration of the feed line, which David touched on some of those points. And David, you didn't bring up that CamGen motion profile generator that kind of automates the setup of the feed line. But Kurt, can you kind of comment on the importance of that integrated and automated feed line, and David then too on that motion profile generator?
Yeah, absolutely. I mean, it's been really, I would say, user-friendly for our die setters to be able to have everything playing off of the same screen, and then just the interaction between the feed and the press is pretty phenomenal. I mean, we almost started toying around with eliminating our short feed sensor on the tool, because the feeder actually knows and would recognize if things were not going the way that they ought to be. We haven't pushed that too far, but we think there may be some opportunity there. So it's been very nice.
Yeah, David, do you have any comments on what you're seeing from either at Concord or other customers out there about the ability to integrate this feed line programming?
Yeah, yes, for sure. Yes, and I think most of the people that is in this webinar will relate to this scenario. Typically, when you set up a new job, you have your press, you define your press speed, and then you try to match your feed performance to that to keep up with the press. Sometimes you can, sometimes you cannot, and it's trial and error. It spends some time. Maybe there are even some accidents with the tool, with short feeds and things like that. Here, we follow a different approach because the system is so integrated that now we start with how fast you can feed in a successful way, in a proper manner that is smooth enough, that you are satisfied with the way it's feeding. Once you understand how fast you can feed, then we can use the cam generator for the press to give just that amount of time for the feed to complete, right? While as before, you just throw in some time, and if it's good enough, if it's enough, it's good. If not, you slow down the press, right? Here, we don't need to do that. We just give you exactly what you need based on the feed performance. And like Kurt said, we have integrated the kinematics. So at some point, if the feed cannot keep up with the time, it's going to send you a message saying, hey, this is not going to work. Don't even try.
That's a process that you perform with every tool then?
Yeah, I would say it's case by case, but then and the majority of the case, maybe 80%, that's how I would approach it, yes. I feed as fast as possible.
And I know too that you spent a lot of time on the floor with Michael, who's the press operator, the primary press operator on the servo, with some extra programming of some tools at the beginning of the project. Talk about, please, that process, tool to tool, kind of how you trained Michael on the press to do that for himself down the road to optimize the stroke profile of that press based on each individual tools.
Yeah, sure. Yeah, and Concord, there's Michael, there's Dimitri, very good people, very smart, and certainly they made the task easier because they were open-minded. That's one of the main challenges that you have when someone starts to work with servo presses, that they are so used to mechanical presses that you have to teach new concepts. For example, just the pendulum, as basic as it sounds, it takes some time to understand it, how it works. And Michael and Dimitri, they caught up very, very fast. But what I tell every operator or every place I go that work with servo presses is a lot of people, and this is a global trend, not only in the US, it's Mexico, it's Canada, US, Germany, France, Spain, everywhere in the world. They kind of follow the same strategies when working with servo presses. They just go and enter speeds in the motion profile out of nowhere, right? They just kind of guess those speeds to what they feel is the right speed. But there's no logic or methodology behind it. So when working with Michael, we started from scratch. We worked in a conventional mode. We found the bottlenecks, the speeds, the right speeds at which each stage in the stroke was working well. And from there, we review what type of different motion profiles existed and how to enter those speeds into the motion profile. It's a sequence.
And David's being a little humble. He's a very good trainer, and the guy was able to get across methodology and concepts versus just okay, yeah, you push this and push that, to where my guys were able to walk away from that training and really move forward. We've got about 30 tools we run across that press right now, and these guys have been able to go in based on what David taught and set up the profiles, and really have seen the same kind of results on all of them.
Thanks, Kurt. Thank you. And I want to say, when you have a servo press, servo press can be very fast machines, but really the juice is in using them properly. Like, you can have the fastest servo press in the world, and if you don't know how to use it, it's meaningless. So it's not just pushing buttons; it's understanding what buttons and why.
Yeah, and Kurt, you mentioned the 800-ton that's going in here early next year. And I think you said when I visited you guys that was for some higher strength materials. What materials are you running through the current, the 440-ton press, and what do you expect to run through that 800-ton?
Yeah, so right now primarily it's 440, 590, that's really the bulk of what we have going through the current 400. We anticipate that the majority of what we get is going to be in that same range, but they're definitely, through the electrification of vehicles, they're lightening them up and using thinner, more, higher strength materials. So we just wanted to put ourselves in a position that we don't have to be concerned with that. With the feed lines and with the press, we can really take on anything that may come at us.
And that 800 tons of progressive die press as well, too, just like the 400.
That's correct. Yeah.
Okay. The 30 tools that you moved over, how did you select which tools to put on the servo press?
Really, what we did was we took high runners, and we took ones that you were going to get the biggest bang for the buck, have less overall changeovers. So it was big volume tools was really what we targeted, just because you could, with that stroke improvement, you could get a lot of bang for the buck out of them. So, like I said, when we were just about double stroke, so things that would take us, be in the press for a day and a half, it's 3/4 of a day, and they're in and out and on to the next one.
Yeah, I know you've done some math, right, in terms of the number of strokes that you've been able to add to your capacity.
Yeah, I mean, we currently only run 2 shifts in stamping, but it's about 3 million parts a year per shift that we see improvement on that. So, when you look at capacity and look at how much business you can take on, it's a big deal. So we've been very happy with it.
Can you
Greg,
speak
you'd also
to
mentioned
benefits that maybe you've been able to quantify, whether it's in the tool room or, sometimes you hear about, tool life being improved or energy efficiency. Servo presses are more efficient than conventional mechanical.
Yeah, definitely. I can speak to the tool room right now, and we're still collecting data to see exactly how many hits each tool can take on top of that. But right now, our data is showing us that we're about 50% less time in the tool room post run. So for
Yeah, it is. Go ahead, Kurt.
Kurt, I think you're muted.
Yeah, I was muted. Sorry about that.
No worries.
Yeah, we're seeing about an easy 50% drop in our the amount of time our guys have to spend on the tools. So sharpening, any kind of PM work, because really you're able to go in, touch steel, and really just come down soft. You're not working the tool hard, and really you're not working it harder at all. You're just being easier on it because you're coming through that bottom of the stroke in a more gentle fashion. So it's I think it'll play out big dividends overall.
Excellent. Thank you for that. We do have a question from one of our attendees. And again, if you've got a question for Kurt while we have him here, or for David, please go ahead and use the Q&A panel. So the question is, we've just started dialing into the ideal SPM for their servo presses through the working portion of the stroke for different types of materials. So David, the question is there a common methodology that you follow or that you would recommend in this case for determining and calculating, the various speeds and feeds for let's say a servo press, in this case, a drill or an end mill?
Well, yeah, the speed certainly will depend on the tool type, the operation that we are performing. It's not the same to draw than to blank, to cut, right? And the material thickness, the material strength, right? But obviously, because all of these are variables, and there's not such a thing like saying for DP800, 1.2 millimeters, it's 20 SPM. No, there's no such thing like that to answer that question. However, there's one way to do it, and to help you finding those speeds is to use your load signature in the tonnage monitor. Most of the servo presses, or for that matter, most of the new presses come with a tonnage monitor that includes load signature. At least the GS2400 has it. And when you look at the load signature, you look at the whole tonnage throughout the stroke, not only the peak, the whole tonnage. And if you look at the whole tonnage, you will see that there are peaks and valleys. If you see a very long or deep valley, that means there's a lot of snap through, or you can detect reverse tonnage, and then you can fine tune the speed until that load signature is smooth enough. So that would be the methodology. Look at the load signature until you smooth the curve to a satisfactory level.
Thank you. Yeah, and so that was that part of the training that you conducted with?
Yes,
with
yes, yeah, that's part of the training. We have a load signature analysis in the GS2, and then we show the operators how to understand load signatures. In the past, operators, they are only used to see peak numbers, and if it's more than 100, I stop the press or the press stops. That's all they are used to see. Now they need to become more prepared to understand what a load signature is. Is this a blanking? Is this a snap through? Is this damaging my press? Is this damaging my tool? You can see it in the screen. It's just a matter of understanding it.
Gotcha.
So David, is that one of the approaches you take to optimizing the servo press? I know that some of the manufacturers we've talked to have a servo press, and they might try out the one feature or something, but they don't feel that they have maximized or optimized all the usage of the servo press. Is that one of the approaches? And if so, what would be the next two approaches to optimizing the servo press?
Good question. Yes, yeah, certainly that's one of the approaches to use the load signature, because as I said, sometimes and sadly we just enter numbers in the program, and for many things in life it applies garbage in, garbage out. So we just enter crazy numbers in the program, we get crazy numbers out of the program, and we think our servo press can fly. Then all of a sudden we have to slow down because really we cannot feed, we are breaking punches. So what I tell operators is always make smart decisions based on the tools you have in front of you, in this case, the load signature. That will be one of the strategies. You ask two more. So another strategy I follow is I do not always run in pendulum. I have had a customer that they always say, we have a servo press, let's go pendulum. Servo presses are from pendulum, that's it. But it turns out sometimes you end up slowing the whole process just because you want to do pendulum, because you don't have enough feed time or feed capabilities. So sometimes it's more beneficial to do a full revolution than a pendulum. And it's a case by case. So just have that in your mind. That's another thing. And one more thing I can tell you, again, it happens everywhere in the world, Czech Republic, anywhere. It's you get a production rate out of the servo press based on the numbers that you enter. Let's say 50 strokes per minute. And in production, and many operators can relate to this, they slow down and they end up running at 30. And when I go there, I say, why if the program can run 50, you run at 30? Oh, because this and this and this and this happens. So instead of attacking each of those bottlenecks, they just slow down everything. So that's not a good approach. You have to attack one by one and then just speed up here, slow down there. Then you need a servo press that can move fast. It has to be very dynamic. But if you have it, it's the nice approach. It's the best approach to have.
Excellent. Thank you.
Thank you.
Yeah, thanks, David. Another question from the audience. This is for Kurt and maybe for David too, as you were programming some of the initial setups there. Any particularly tough materials that you've worked with? Stainless steel specifically is the question here. And how did the servo help either with stainless steel or any, particularly challenging jobs? Can you recall any, Kurt or David, as you were programming with Michael, some challenging materials or parts, and how the servo?
Yeah, I don't think we have anything real challenging on ours right now, nor have we tried. But my understanding, based on what we discussed with Minster, both tied to the feed line as well as the press, that it's got heavy capability to take it on should we win some business to that end. But we currently, no, it's everything's just been primarily 440, 590 steel.
Yeah, in terms of strength, like Kurt says, the machine is capable of handling stainless steel, high strength steels, ultra high strength steels, not a problem. In terms of formability, I think some people know in this group, stainless steel is very temperature sensitive. It changes its properties with temperature. So, and the temperature is going to change with the speed, the forming speed, you know. So yeah, for sure, I can foresee that stainless steel applications are a good match for servo presses, where you can control the temperature and therefore the material properties.
By adjusting the stroke profile. Speed.
Yeah, the speed informing, yes.
Okay, for now, we don't have any, well, as soon as I said that, we got one more question that came in. You talked about evaluating the tonnage signature and changing the servo motor speed. Did you mean that the speed vector can be changed during the pendulum or stroke, and a speed signature can be profiled for the part? Is that what you're getting at, David?
Yeah, we get a load signature that tells us if we have sudden drops in the load, and we can slow down at that particular point to prevent that sudden drop, just at that point. So we detect the problematic points, and then we adjust the speed. Yeah.
David, you mentioned the brake, applying the brake. How is the brake applied on the HDX line? And how is the automatic brake pressure adjustment? How does that work?
Oh, well, yeah. Yeah, we have two brakes in the HDX. One is a fail-safe brake, and the other is actually the brake that is working during production. And so we have a laser pointing at the outer diameter of the coil. And based on that, we calculate the width and the diameter of the coil. We can calculate the weight, right? So as the coil is being consumed, the outer diameter is decreasing. So we measure it, and then we calculate the new weight, and therefore the new pressure that is required for that weight, the coil. That's how it works.
Thank you.
Yeah, and this is not a question, but I just want to mention it for a lot of people that is in the line between deciding to go for a servo press or mechanical press, and they think our servo presses is a larger investment, may not be adequate. Depending on the job, for example, the one we watch in the video, we may need to adjust the numbers, but you are looking at about $40,000 a year in hours saved, at least. Okay, so multiply that $40,000 times 30 tools times this, in addition to the savings for maintenance, and then you can cover the difference for a servo press easily. It's just a matter of using it properly. If you get 35 instead of 30, may not be as good.
Yeah.
We've also heard, David, over the years that since servo presses have become more popular, that energy savings can be significant compared to conventional. Have you been able to document that with any of your customers, the energy savings? Or I don't know if Kurt's been able to document energy savings from servo.
We have not at this point. I don't have any numbers I could throw out here as gospel.
Sure.
No, I do not have numbers as well with me, but I can tell you for sure the consumption in a servo press sometimes is less compared to mechanical press. Sometimes it's a bit more depending on the system. But let's say even if in the worst case scenario, if it's 20% more energy consumption, but you are producing 100% more, then the energy cost per part is lower in a servo press.
Gotcha. Okay. All right. Thank you so much. So these guys are going to stick around, till the end of the event. If you've got more questions for Kurt or David, as the event goes on, please go ahead and use the Q&A panel. In the meantime, thank you guys for that. And let's turn things over to Lou for the TNC stamping case study then.
All right, thanks, Brad. Formed in 1985 and located about an hour south of Nashville, in Athens, Alabama, TNC Stamping provides contract metal stamping, as well as tool and die and subassembly services. specifically in 100,000 square feet of space. And with 80 employees, the manufacturer offers tooling design and prototyping, as well as progressive die and deep draw stamping. Initially focused on stamping appliance and electromechanical parts, TNC grew to accumulate more than 60 presses in capacities from 25 to 330 tons. Our topic here, 2 330-ton CE servo-mechanical models brought on to support part production for the automotive industry. Sorry, I got lost. Here today to discuss the servo journey at TNC, Mark Coleman, co-owner and president, and Troy Hardaway, production manager. Also on the panel, Scott Brado, sales director for CE. And Mark, I want to start off with you. If you can set the scene for me. In about 2015, you're initially considering servo press technology at TNC due to possible automotive work. Can you take me back and describe your company's entry into the automotive world and how you came across servos as an answer and why you felt that they might be necessary?
Sure. In 2015, we were approached by a tier 2 automotive company. They were a transplant for a large automotive assembly plant. And being located where we are in the Southeast, we're surrounded by automotive companies. And so half of our business prior to that is in the appliance industry. And they're just, to grow in the appliance industry is just not a real good growth strategy for where we're located and for the amount of work that has left this country. So we knew that to not only grow but just to stay in business, we had to take advantage of some of the automotive opportunities that were around us. Fortunately, we got that opportunity in 2015. And the idea was, well, maybe we can get 2 or 3 parts and, just kind of dip our toes in the water, learn the ropes. And then whenever the model change comes around and, the next 7 years, we'll be a lot, better versed in how to play in that market. We ended up getting about 25 parts out of it. And at the time, the largest press we had was a 200-ton Niagara as a straight side press. And that we ran several draw parts on it, but that was the largest press that we had. Once we got the tools in, a lot of the tools were proved out on that press, and we made it through the tooling tryouts and the pre-serial production. But as we started to get into the serial production, I was losing sleep at night thinking about, man, if that press goes down, we really don't have a backup. And I know for the automotive industry, at least for us, we've got to minimize our risk and make sure that we've got redundancies there to take care of that. So I had been familiar with the concept of servo presses and the my background being machining. The analogy that I used was the typical machining cycle is there's a rapid in, and you get the feed stroke, and then you got to wrap it out. Well, with a typical mechanical press, it's just one speed, and that one speed pretty well has to match what the bottleneck speed is, so with one particular part, and when in the video coming up, you'll see a part in there that to get that shape, there's a form. It's actually that's actually a drawn part. It's not just bent over. So the servo press is particularly well suited for that part. Going back to the 200-ton Niagara that we had, I mean, it sounded like a shotgun going off on some of those parts just to snap through. And I just grit my teeth thinking, oh, man, that can't last. So being an owner, and we don't have unlimited funds. I had to make sure that we took our best shot with whatever servo press that we bought. We've got had a long-standing relationship with the folks at Shea, and I did as much due diligence as I could, but I'd say 50% of the decision came down to trusting those guys and not knocking anybody else's servo press. I mean, it just a lot of it was the relationship that we had with those guys, and so we took a gamble, went with it, and it's just night and day difference in how the parts have run. I want to echo almost every point that Kurt and David made at Concord. We saw all the same benefits, but just you can just hear the difference. Also, the point that David made about matching the feed line with the servo capabilities, we learned that the hard way. Also, we bought a really good feed line. Well, in 2018, we bought our first servo press, but the feed equipment that we used was just something that we found at an auction. It wasn't necessary, and we had a about a 350 megapascal part that was going through there, 187 thousandths thick. And we noticed that on the new press that we bought in 2019, again, another 330 ton servo, it ran much better, but it had different feed equipment. And so I learned the hard way, the feed equipment does matter. And so we went back and matched the feed equipment on the first one, went back and bought the same feed equipment that we had bought for the second one. So I haven't regretted it a bit. And so we've got another project coming up. We've got two 330 ton servos that are sitting there ready to go with this next project that's coming up. Tools have been built, and we're anxious to get into the proving out the tools and getting started with that project.
Just like the potato chip commercial, you can have just one.
Exactly.
For automotive, but and also we'll be talking in a few minutes about the those other line items there. When you bring in servo presses, you got to mind the feed and the other things. We heard that earlier, and we're going to explore that a little more here. But first, I want everyone to take a look at this video that was shot about those CE series SD2 servo mechanicals. And I think we have Weston Coleman, Director of Sales at TNC, who's narrating this. So take a look.
TNC started in 1985 as a stamping facility that primarily focused on appliance and electromechanical type parts. We've been here for nearly 40 years now. We have 100,000 square feet here in Athens, Alabama. About 8 of our 60 presses are CE presses, but they are our most critical presses. We have 2 330 ton, and then we have 4 275 ton presses that run is from the time our doors open in the morning to the time they close in the afternoon. They carry quite a load because they are the presses that we depend on more than any other presses. Any large press we buy from now on will be a servo press. There is really no going back at this point. The operators love them, tool makers love them. In my opinion, it has changed the industry altogether, not just TNC, but servo press technology is incredible. And we've seen those benefits firsthand here at TNC. So the servo press helps us produce more parts than a traditional mechanical press. Stroke speed is as much as 30% faster than it would be in a traditional mechanical press. There have been significant gains in throughput efficiency with a servo press, just from the things like the pendulum motion, programmability, reducing the setup time. And then you have things like the variable stroke speed. Another thing is that it sends a signal to your customer. When you're willing to invest in the latest and greatest technology, it sends a signal to your customer that says, hey, we're here to stay. We plan on being the best supplier you have. That does give us a little bit of a competitive advantage.
Troy Hardaway, who's the production manager at TNC, he certainly can speak on what this type of technology has meant for TNC. So can you kind of describe these press capabilities as compared to traditional presses at TNC, and what have they allowed you to do in your auto part production specifically?
Well, excuse me. I like what the other guys have mentioned. It decreased our setup times, increased our productivity. We've seen a lot better quality in our parts, less maintenance on our dies. Weston said the die setters really enjoy or like the presses. They really enjoy what they've nicknamed the whirly bird, which is the handy pulser, where they can adjust the ram to where they want it without having to bump it around like you do a conventional press where you have to inch and bump around. We really worked out well for us.
And now, Scott, if you could expand on that and talk a little bit about, the technology on these types of presses and what they are bringing to the table in terms of both their ability to, combat snap through and also, motion. I think pendulum motion was described here. And, if you could talk a little bit about that technology for us, Scott.
Certainly. Yeah, so kind of like what Troy was talking about, there's a lot of different ways to really use the servo press its full capabilities. Having the full control of the slide programming, almost like you would on a CNC machine, where you can slow down, speed up, change direction, anything there through the stroke of a press, which can never be done on a traditional mechanical driven press on there. You can use the pulse wheel to go down and really find your key transition points in your tooling. So you're eliminating any wasted time where the press is actually not contacting the metal on there, and eliminate that in there, which allows you to increase your productivity. Some of the more advanced motions, not just pendulum. The pendulum's great because, you're not going full 360 degrees rotation, and allows you to get that higher productivity. But you can also do more advanced drawing operations using maybe a vibration. You can do a restrike right in a single die station in the die, so you don't have to build in additional stations in your tooling, and get a lot more of those secondary operations that would maybe have to be done outside of the press into the press itself. And so you can free up a lot more space in your plant, get a lot more productivity, and a lot more finished part coming off the press itself.
Okay. And obviously you had two presses coming in here. So the second one is probably easier, having people up to speed and everything else. But for your first foray into servo, can someone from the team talk a little bit about the kind of training, like what into bringing people up to speed in terms of operating that machinery, and also in making sure you had the right ancillary equipment and you had the ability to keep these presses fed and everything else? So please comment on getting the people and the equipment up to speed to deal with this technology.
I think Troy's probably in a better position to answer that, but let me just kind of set the table for how the press ended up in his area of responsibility. Troy is just wonderful when it comes to being open-minded about new ideas. I think David mentioned that earlier about having employees that are open-minded because it is different, and especially somebody that's been in the setup world, or all they've ever known are mechanical presses, and it's different. But Troy's very open-minded about things, and that was just a great environment to put it in. Troy was a setup person for years before he became our production manager also. So he's got the technical background for it. And so, but anyway, I'll let him, talk about the specifics of the programming and the training.
Yeah, I don't know how technical it'll be. Excuse me. As far as the operating of the presses, there wasn't that much difference between the conventional mechanical presses. The programming, we had to do some training for the guys from Chahi that came here to set the presses up. They actually showed me, trained me on it, and then I took that and trained the setup guys. And right now with the 15 or so dies we run in those presses, we've got everything programmed to, we're running the pendulum motion, half motion on everything we're running right now, with a slow down through the forms, through bottom, and a speed back up to the top.
Yeah, and even on some of the training, that's one thing that we're trying to make sure that all of our customers are getting the most value out of the investment they're making in these presses. And to do that, it's an ongoing process for training. Having the customers and the users of the equipment have a champion or a couple of people that are going to be spearheading those in their facilities is absolutely critical, because you go in, you can do the most training as possible, but if they're not willing to learn it, accept it, and their team willing to implement it, it's it's kind of wasted time and money for them. What we've done, we've had some customers in the past, again, where David kind of talked about, maybe if everything's running too fast, the operators might get scared, and then all of a sudden they're backing back down. We had a customer that did that, where we had done a pretty thorough optimization training for about a dozen or so dies with them on their first shift setup, had everything set up, ready to go, came back in, the exact part was still in the press the next day in the morning, but everything had been back down to where they had run it previously, because the third shift operators weren't really involved in that process and didn't really understand it and didn't like the added speeds. They got scared, everything, so they backed it back down to that. So it is an extended buy-in, on everybody's side to make sure that everything is going to be working properly and doing that.
Okay, thank you, Scott. And I thought there was an interesting point in the video where it was mentioned that it's serving automotive, investing in this type of technology. You're really telling your automotive customers that you're in this and you're for real, and you're gonna be there for them. And I think it helps having that technology when you're seeking other automotive work, or you want to develop that long-term work with your automotive customers. So if anyone would like to comment on that, I don't know if you might want to, Mark, or also some of the other challenges that you found were met in bringing in this technology that maybe you weren't aware of when you were shopping around. Like, what have you found since that, boy, this really surprises me?
A little bit of a story. We saw a video from one of our competitors, and they got a same 330-ton servo press on their floor also, running very similar parts to what we do. So it kind of validated that for the size range that we're in, that a lot of people have come to the same conclusion. And the 330 tons are that's we don't have a press larger than that. We're not in the 400, 600, 800 ton range. As far as the feed equipment, we had a hot roll part, again, about 187 thousandths thick, 355 on the tensile strength. And again, like I mentioned, it ran pretty good in one part, one press, and then in the other, we just couldn't seem to get it right. And it ended up being a mismatch on the feed equipment. And so kind of found that by accident. But again, certainly won't make that mistake again. We'll, the largest or the highest strength material that we run in those presses right now is about 420. And so the feed equipment that we have is certainly capable of running those parts.
That's a huge takeaway from your side is, my net feed equipment. And with that, I think we're about ready to move into our general Q&A session with our audience. And Brad, if you want to take that over.
Yeah, we got a couple questions in the Q&A box as we speak, and we've got plenty of time left if anybody else wants to ask these guys questions while we're lucky enough to have them online with us. I think, so one of the questions talks about the relationship with the die designers and the die builders in our industry, and it's kind of a question I want to expand on with David and Scott and what they've seen in the marketplace since servo presses have become so much more popular. Is the die community really aware of how much faster dies can run, how much maybe less maintenance cycles they may need by running in servo? The specific question is, the die suppliers have a recommended speed to run the dies that they build. And when you run the die in a servo press, do you need to run at the specified speed from the die builder, or can you run them faster? And if David and Scott want to address that, but I'm interested in the bigger picture of, are we designing dies differently now for servo? Can we stamp parts that maybe you couldn't stamp before because of servos? And are the die builders kind of clued into this whole process? So I don't know if Scott, maybe you want to take that one first, and then I want to see what David has to say as well.
Sure, I'll certainly start with that. Yeah, I think like with everything with the servo presses, they've been around long enough now that more and more people are getting more comfortable with them and their capabilities and learning how to kind of change their die designs and what they're doing with them. That's one of the biggest questions we always get asked is like, okay, well, how do I design my dies different, or do I design my dies different for running in a servo press? And I think there are some things, like we talked about earlier, maybe bringing some of those additional secondary operations in there, doing some of those within the die itself so you get a more complete part coming off the die. As far as the speeds of it, again, I'm not a tool and die designer by any means, so I don't want to say something maybe out of sorts on here, but yeah, they're going to have a recommended speed that they try and do that. But I think there's always, safety factor that they consider in there. And so, being able to use the servo presses and running them faster is possible with most dies and what you're getting out there. I don't know, Dave, do you have anything else you want to add to that?
Yeah, sure. Well, I think, as we work with more servo presses, people is understanding better what they do. But sadly, in most of the times, we really do not understand where that limit is coming from. And I can do one exercise today. Go and ask your tool maker, why 20 strokes per minute? Why 30? Ask them that question, plain and simple. And most of them will not give you a straight answer, right? Because what's the limitation? We need to understand, can we run more than 30? No, because we have problem temperatures. The die gets too hot, that the lubricant evaporates and doesn't work. Is it temperature? Or is it the springs that are designed for certain inches per second? And if we move faster, we are going to break the springs, the seals in the cylinders, right? And that will depend, of course, in the press stroke. It's not the same dealing with a 20-inch stroke with a 10-inch stroke. So we really need to understand what's the problem inside of the die, or what is the reason why the die maker is limiting that speed in the tool. And I can tell you, maybe 90% of the time, it has to do with mechanical components and part stability. Like something is breaking if we go faster, or the part is not stable, and then we have problems transferring it or feeding it. Or sometimes it's even the feet, or sometimes it's even the fingers in the transfer that are limiting this speed. So you need to understand what's the limit, and then you can correct it. And to give you one example, I was in a plant here in Mexico, and they were running at 20 strokes per minute. And I noticed this job can run so much faster. And when I told them, do you want me to take it to 30, 40? They said no, because tool room said no more than 20. I said, okay, we can keep it 20 in the bottom and then just increase somewhere else. And it was a whole show. They called like the plant manager and everyone else to approve that production rate increase, because the tool room was concerned going beyond 20 strokes per minute, because they concerned about the forming portion, but they were also limiting the upper portion of the stroke. So to answer Jonathan's question, I think you should always accept the recommendation from the die maker in the bottom of the stroke or through the bottom of the stroke. In the other portion, aerial portion, you should go as fast as possible. And most likely you will get a much higher production rate than the tool was designed for. I want to expand because I have something else to say. If you notice your tools, go and check how much room, especially with the lifters, especially with deep draws or deeper parts, go and check your lifters. If they are taller than enough, which is the case in many times, you are wasting time in your production rate. You're wasting time in your cycle. So the lifters is one thing that new or tool makers should consider when they are building tools for servo presses. Yeah, those are my 2 cents.
Yeah, that's really good. Thank you. Thank you.
Just tossing in a couple other thoughts to that. And we also build all our own tools at Concord, as well as tools for others. But one thing we've noticed, and David kind of touched on it when he was talking about our processes, is a lot of those things that are the reasons you don't run them fast with a conventional press. You can run them faster, even though the actual stamping speed is no different than you were at 30. You gain all that back because of your process wheel. You're really cutting out the upper V, the front end of the stroke and the back end of the stroke. So what we found is we're not really pounding harder through the stroke. It's all in the upper section. So I think the processing, and like David was talking about, where you find those high tonnage points and kind of massage the process. But use of nitros versus springs and certain things for return purposes. Also coating of details we've recognized as a big deal as well in order to do that, because I would say they seem to cool a little better, right? They don't absorb as much heat, and so coating of details we found to be a big deal, and we'll learn more about that as we go forward.
So Kurt, you have made adjustments to your tool coatings in some cases based on the speed of the servos?
Yeah, we've been trying a few different things, working with a local coater that we use here,
Okay.
and going after some of their recommendations, and seeing some good things.
The guys at TNC have any comments to that? Have you done similar? Mark, have you?
Trying to find the unmute button. The part in that video, it's coding is critical on that because of that draw operation, and but it again, the servo gave us the opportunity to have the right feed rate as it went through the draw portion of that stroke. And but yeah, like Kurt said, the coating is that's part of the equation, critical part.
Good. Okay, another question we got from our audience deals specifically with stamping electrical knockouts. So maybe David or Scott can comment on can servos help avoid shearing in the die and accommodate variations in different batches of raw materials? So I'm sure Kurt and Mark, you see this raw material variation and material properties and different amounts of shearing issues. Can you speak, David or Scott, specifically to customers that are doing knockouts? I don't know who wants to go first. David, you want to go first on that one?
Yeah, well, to be honest, I don't have that much experience with that application itself, but I can tell, well, if without knowing it, if it's speed dependent, for sure, we will, the servo press will be a good match. If it is position dependent, I will hesitate.
Okay, thank you. Any comment on that, Scott, or?
Yeah, I'm, as David said, I'm not really familiar with that electrical knockout application and process. I do know that just on other applications with material variations, being able to fine tune the servo press, like I said, doing slide adjustment and the slide motion profile speeds, whatever you may be doing, can sometimes help compensate for material that may not be up to the spec you're wanting, allow you to not have to reject coils in that and still be able to process them.
Okay, thank you. Anybody have experience with in-die tapping in the servo? I don't know if Kurt or Mark, if you guys do in-die tapping, otherwise, maybe David and Scott have some experience with customers that are doing in-die tapping with their servo press. Let's see, Kurt, you want to go first on that one? Are you doing any in-die tapping?
Yeah, we do have a few tools that are in-die tapping, but none of them that are running in the servo. But I don't believe that there would be any more difficulty within the servo, and probably it might even be a little better, just because in a standardized press you're going through everything at the same exact motion, the same exact speed, whereas as you're coming into the tapping operation, you could probably control that through that motion to get the most optimized tap out of it. So I would think it would be significant. David, I don't know, you might be able to answer that also.
Yes, I think there are two main ways of doing in-die tapping. Of course, one is mechanical, and that is going to be linked to the press. And of course, if you can control the speed of the press, like Kurt is saying, you can do it smoother, let's say. And there's servo in-die tapping, which is very popular nowadays. And with servo in-die tapping, the servo in-die tapping, it's its own animal, right? You have to put the parameters for this process, and then you will get a time required for that in-die tapping. And then once you have that time, then you can program your servo press to match that time. Okay, and here, this is again what I wanted to say about the GS2 control, that we don't only control speeds, we also control time. Sometimes you have to guess the speeds to give the time. With this press, no, you just say half a second, and then we adjust the speeds automatically to give you half a second. So yeah, I think it's a good application, servo in-die tapping.
We have one one in-die tapping job. It's a 5/16 left hand going through 410 stainless that's been that has an extrusion on it. Right now it runs in a mechanical press. If that job was going to stick around, it probably would run better in a servo press. But in the servo press, we do have a job that we were running. It's in-die insertion of a couple of studs that get inserted into that 187,000 thick material that I was describing earlier. It's tied to a feeder unit. So the being able to tie it in with the cam positioning with the servo was probably a lot easier and gave us a lot more capability than doing it with the capabilities that we had with the limited amount of cam switches that we had on the mechanical press.
Excellent, thank you. Any other comments, David or Scott, on in-die tapping? I think we covered it pretty well. Question from the audience, I guess for David and Scott. comment on the popularity of servo presses versus conventional mechanicals today, and how you see that changing over the next 5, 10, 20 years, if you can look out that far. Based on what you're seeing in your own companies or what you're seeing when you visit stamping shop. You guys are in a lot of shops. Where do you see servos going in the marketplace compared to conventional mechanicals?
I
You
mean,
wanna go
I
first?
certainly see the servo market as a growing market. Every year, more and more of our customers are getting a servo press, whether it be their first one or once they have their first one and really have had the time to learn about its capabilities, what it can do, to adding additional ones to that. We still sell a very large number of traditional mechanical presses as well. There are some kind of simple applications that I think those always sort of be the best thing for, but I would say long term that more and more mechanical style presses will be replaced by servo mechanical presses.
Yep, I agree. I agree with Scott. I think servo press market is growing, but certainly I think there's the way I see it, I think it's going to be divided based on press size, maybe all the way small presses, very small presses, all the way up to maybe 2,000 tons. I think servo presses are perfect candidates, and in 90% of the applications you will get higher production rates. But when you go beyond 2,000 tons, I think there's going to be a struggle between or a good fight between servo presses and mechanical presses, mainly because the size of the press is going to limit the speeds. So yeah, I think in that range, it's going to be an interesting fight. But below, under 2,000 tons, I will always go with servo press myself. And it's not a question that someone asked, but I want to tell, I'm sure some people here work with transfers. When you work with transfers, how do you pick your press? You have to consider the stroke length, right, for transfer time and things like that. So with servo presses and transfer, it's a perfect combination. You can go or get by with a shorter stroke because you can control the transfer time. You don't need to open the full stroke. You just need to open enough to move the part forward. So
yeah, that makes sense.
I have a question related to that. And I've just been in some stamping shops that have, 20, 30 mechanical presses, and they have not gotten any servo presses in. And when I asked about that, they said, we're just not really sure that the additional cost is really worth it. So this question is really for kind of Kurt and Mark. How did you evaluate the ROI on purchasing, a more expensive servo press versus staying with a mechanical press? Maybe I can start with Kurt first.
Yeah, sure. I don't know that ours wasn't necessarily looking at it like that. We were more looking at what business is to come. We've already, in the past 5 years, we've doubled in size. We anticipate to do that again over the next 3. Kind of those numbers I put out there at the first, where you improve by 25 strokes a minute on what you're capable of doing. That's 1,500 parts an hour. That's across 3 shifts, 9 million strokes that you could be adding additional tools, additional business, which then, pay off in profitability and the affordability of bringing in one of the presses in. But yeah, if I could start from scratch, they'd all be that way.
I wish I could tell you that I had a really fancy algorithm that calculated our ROI, but again, going back to what I said earlier, being the owner, it's my money, it's not somebody else's money, and quality is a huge consideration for us, and just conceptually being able to mimic that feed cycle of like a rapid in, a feed stroke, and then the rapid out, knowing what that would do, for our tool life. I mean, there were just a lot of intangibles that I knew would come out of it that would be difficult to put down on an ROI spreadsheet. So, intuitively, I knew the benefit would be there, and it's been night and day difference in the and what we had with the mechanical press that we had.
Interesting, thank you. And I think your associate said we'll never go back to mechanical presses.
Yeah. That's with a large press. I just again having that extra capability, like Kirk said, just knowing where the parts are going as far as material and just what you have to be able to do with the press. It's not enough just to have the force and bang it out. I mean, you got to have those capabilities and be able to do have a lot more capabilities at the bottom of the stroke. It's not and then the productivity. You just got to take all those things into consideration, and typically that's just not there with a traditional mechanical press.
Thank you both.
Yeah, thanks, guys. One of the other issues that sometimes comes up, when you're increasing your stroke rate by 50% or double or triple in some cases, is you're just moving the bottleneck maybe to the end of the line. So now you're just, how do we handle all these parts coming out of the servo press? And so I remember Kurt, at your place, I saw you guys had some tote coats, I think, right? To kind of automate a little bit some of that end of line. Did you, and same question for TNC, did you plan end of line issues during the servo press evaluation process, or did that happen later where you had to realize?
Yeah, that for us, that happened a little later because we got we're into some smaller parts, and most of the parts we make will fit in my hand, they're body parts for Toyota, that kind of thing. But we do have a number of 36-inch long narrow parts that you can slap those things out, and they're coming in, and the operators at the end of the line have to stack them, right, in order to pack them in properly. And we found that we ended up having to on that part, I can't run it through a tote goat. And so, it was adding another operator to be able to handle the amount of parts that were coming off the end when we run that tool. So.
Yeah, thanks. How about you, Mark? Any issues with end of line?
Yeah, when I quoted the parts in 2015, it was, again, a lot of our parts are smaller. Also, we were running into large totes, and that would end up going to plating or heat treat, that kind of thing. And so I kind of missed it on the quote as far as considering only being able to run 30, 50 parts of the larger parts into a tote at a time, just for volume and weight considerations. Fortunately, we have a great maintenance crew that's able to that was able to work with the conveyor off of it and have a chute that it was tied to a counter that would switch it back and forth, so you don't have to shut the press off and then restart it every time to whenever you get to a swapping over totes. But yeah, material handling was something that we found out after the fact. That was a lot of times the production is limited by the material handling and not so much the press. So, but we found ways around it, and interestingly, we found that if putting two people there, and it's the little stuff like taking barcode labels out of the totes when they come to you, and then printing labels, and so we've for us, we found that we're more productive with two people there, or at least a person and a half, with somebody taking care of the material handling issues, and the press will outrun the person in most cases. So we've that ends up being our bottleneck in a lot of cases.
Good, thanks, guys. What about, I don't know if David or Scott want to address this one about die stuck on bottom. Does that happen with servos? And if it does, how do you address that? I don't know, David, have you
Yeah.
seen that?
Yeah, I've seen it once in my life only. Yes, several, yeah, out of hundreds of servo presses, only once. Yeah, so what happens is servo presses have a lot of torque, instantaneous torque, so they almost never get stuck in bottom. You can go through the bottom, the center very easily. And this time it happened. It was actually, I was helping a customer with a press from another manufacturer, 2,000-ton transfer press. And we put the press at bottom dead center and went for lunch. We forgot about it and went for lunch. So when we came back, all the oil in the gear and the shaft was depleted. It was at the bottom. So we had a lot of friction. So we struggled to move it even with the torque of the servo motors. There's a very easy solution for that. New presses come with hydraulic overload protections. Just release the overload protection and then you are free to go back. It's you don't need a lot of help to get back in a good position.
How about you, Scott? Have you seen that?
Yeah, I don't recall ever seeing a servo press stuck on bottom. Again, I'm not saying that it can't happen, but like David said, it's extremely rare if it does. Another feature that we have in our servo presses is, in addition to the hydraulic overload, we also offer an electronic overload, which is basically programmed to whatever individual job you're running. So, if you've got a 300-ton press, you're only running a 100-ton job, you can set your electronic overload to detect, 5% over that. And if it does hit that, for whatever reason, the press will automatically reverse itself before it even gets to bottom dead center. And so, again, they should be capable enough to prevent even getting stuck to begin with.
All right. Excellent. Thank you, guys. Don't have any more questions. We're pretty much at the end of our time. So thank you to the audience for those great questions. That is a wrap on another edition of MetalForming Live. Thanks again to our panelists, all you guys for being here with us today. And to all of our attendees, we here at MetalForming Magazine and PMA wish all of you a joyous holiday season and a healthy and very prosperous new year. We will see you again in 2025.
Thank you.
Thank you.
We're so glad you could attend. Come inside, come inside. There behind the glass stands a real blade of grass. Be careful that you pass. Move along, move along. Come inside, the show's about to start. Guaranteed to blow your head apart.